This podcast was produced by OAR FM Dunedin with support from New Zealand On the Air.
Welcome to the OI podcast, the Otago Institute podcast, conversations with experts from the worlds of arts, sciences and Mātauranga Māori. Brought to you by the Otago Institute, the Otago branch of the Royal Society for Arts and Sciences. Kia ora, no mai, haere mai, and welcome to 2026. Gosh, Trudi, did you ever think we were going to be saying that?
Oh, I hope so.
For those of you new to the OI podcast, Happy New Year and welcome to the OI podcast. I'm Dr Barb, a quantitative ecologist with a background in modelling, climate change, biodiversity, conservation prioritisation and SciComm. I have a PhD in botany from Otako Whakaihu Waka, the University of Otago.
Oh, that's quite amazing, Barbara. Whew, what a lot. And I'm Trudi, surprise, surprise, and I have a background in the humanities and sociology, international relations, domestic politics, economics and life. So I'm a jack of all trades and a master of none.
And extremely skilled in keeping me just really under control there as much as anyone can. We hope that you enjoy our mix of conversations with experts in as wide a range of subjects as we can find from the worlds of arts, sciences and Mātauranga Māori. For those of you who are old friends returning for the new year,
welcome back.
Welcome back. Yeah. Last year ended on a high with our OI election special where we broke all sorts of listening records. Thank you, everyone. We really, really appreciate that support.
Yeah.
And our amazing listeners out there. And we hope that you weren't bored crazy with all our politics talk. And you've come back for this exciting new year. We're hitting the road running this year.
We're so organised.
It's
just a bit of a worry, but, we just start as we mean to go on, and
yes.
we will.
Yes, and we're very excited about this year's OI podcast series. We've got amazing speakers coming to talk to us this year, and we are starting off with a bang. We've got 2 international guests.
Yes, aren't we so privileged?
We are great. So thank you for sticking with us. Happy New Year and welcome back. We hope you enjoy our 2026 year. I'm Dr Barb.
And I'm Trudi.
And we are in the studio today with Dr Jenny Hodgson talking about connectivity and conservation prioritisation. Welcome, Jenny.
Hi, Barb. Hi, Trudi.
Hi.
And thank you very much for coming along today, Jenny. Jenny is here all the way from the UK winter, where she is a reader at the University of Liverpool.
A reader? That's not to be confused with that German literature book called The Reader.
No, it's a completely different thing. But I think New Zealand listeners will be familiar with the term from University Challenge. Because the contestants always sit there and say, I'm X and I'm reading something at Oxford. I'm reading history at Oxford. So, and I'm pretty sure it comes from the same place, does it, Jenny?
Maybe. What it means is I'm not a professor yet.
Yes, but more than a lecturer.
More than a lecturer.
Yeah, so it's sort of
a hierarchy.
It's a hierarchy thing. I think it's sort of like
an associate.
What in New Zealand would be an associate professor.
Ah, very cool.
I think that's really where it sits.
Right.
But it's kind of heavy on the research as well. Mm-hmm. Yeah. Anyway, well done.
Yes.
Jenny is a conservation biologist with a BA in natural sciences from the University of Cambridge in the UK, because I recently realised there were Cambridges in other places of the world.
But there's only one University at Cambridge.
I think there's a University of Cambridge in the US.
Yeah, but it wouldn't be the University.
It wouldn't be the University of Cambridge. That's true,
yeah.
Anyway, so just in an attempt to not assume that people know which university I'm talking about.
But there is only the University of Cambridge.
Yeah, and I learned something today as well. Did you know that the University of Cambridge does not have a BSc?
It doesn't?
No, because Jenny has natural sciences and I was like a BSc and it's just a BA. It's weird. It's
one
like
of those weird historical things.
It's one of those weird historical things, yeah. It's like a PhD is a doctorate in philosophy. Even though my doctorate was majoring in botany, it's still a PhD, as is everyone I know who has a PhD. I'm just trying to think. I do know a couple who have a philosophy PhD, but very, very...
There must be philosophy PhD people out there, come on. Yeah.
Yeah, of course, because there are departments of philosophy, that's true. Anyway, so Jenny, BA in Natural Sciences from the University of Cambridge and a PhD from the University of York, which of course is where I met Jenny.
Oh, and York's a beautiful town.
And York's a beautiful town. The university's a beautiful university. In general, Jenny's research revolves around how the spatial arrangement of land use and management affects the viability of species. The amount and pattern of nature reserves and green spaces strongly affects whether species can survive under climate change. Jenny uses a mixture of empirical and modelling approaches to investigate how species are already responding and what might happen in the future. Starting in 2020, Jenny is funded by a UKRI, which is the UK
Research and Innovation. So this is the government funding for research.
Yeah,
it's the major government
it's like our
funding for
MB,
research.
Marsden
UK.
Fund, which
cool.
is also in the process. Let's not talk about that. As a Future Leaders Fellow. So again, and I think that you've just had that reconfirmed for another 3 years, Jenny.
That's right.
Yes.
Yeah, I'm very lucky.
Very skilled. Very skilled.
Well, I was going to say, from someone from Liverpool, you don't have very much of a Liverpudlian accent, but then having just heard your bio, Cambridge and then York, so...
Yeah, my parents were from the south of England and I learned to speak before I moved there.
Which is a good thing, because I, in a previous life, worked at the Bank of New Zealand, and we had a good friend who used to play darts, came from Liverpool, and whenever he came in the bank, everybody else had run away, because I was the only one that could understand at least one of the 3 words he spoke. So,
oh, wow.
Yes, a very thick accent. But anyway, that's by the by. So,
we're talking about connectivity and conservation prioritisation, which has been a bit of a focus of yours for, I think, ever since I know you.
Yeah, ever since my PhD.
Yeah, pretty much.
So connectivity, like in our world, that's all about how do I connect to the Wi-Fi, but it obviously has quite a different perspective for an ecologist. So perhaps you could just expand on what that means for you and how you use it in your research.
Yeah, it's not a world away from what we think of as connectivity. So if something is connected to something else, it's easy to get between them. And if something is not connected, it's more difficult to get between them.
True.
Fundamentally, that is. Connectivity we use as an umbrella term, and it can be that different conservationists and ecologists use it in a slightly different way, because some people will be thinking about one exact species and whether it can get from A to B, and some people will be trying to summarize how connected a landscape is from the perspective of lots and lots of different species. But all species really have their own ways of getting about and their own barriers. So something that's a barrier for a snail is not a barrier for an organism that can fly, for example. So we often say that connectivity in reality out there in the world is very, very species specific. But for conservation of landscapes where we don't understand a lot about all the species, we need to get some kind of general idea of connectivity that's roughly right for lots of species.
Yeah, because you could be in danger of making one species even more connected, but then shutting another one out. So, yeah.
And I guess also sometimes as conservationists, perhaps not so much in the UK, but definitely here in New Zealand, we want more connectivity for some species, the native species whose distributions maybe are fragmented. But obviously for invasive species, we quite often want less connectivity.
You
so
want to inhibit connectivity
so
for pests and diseases and invasive species.
Yeah.
Absolutely.
So it's quite an interesting kind of study of that species specificity, and I guess also breaking it down into different types of habitats as well. So, sort of trying to make lumping groups of species together based on what type of habitat they like the most, whether they're kind of edge of farmland species, which I guess is more of a thing in the UK perhaps compared to New Zealand. But, we have a lot of areas in New Zealand that used to be bush, for instance, native forest, native trees, and they've kind of been fragmented through fire or clearing or whatever. So that would, I guess, lessen the connectivity for those forest bush species.
Yeah, so connectivity depends on the availability of habitat. You can destroy connectivity by just destroying habitat, and it also depends on the spatial arrangement. But if you don't have enough habitat to start with, then it's almost impossible to create the connectivity, if you see what I mean.
Yeah.
It's very important to think about both the amount and the spatial arrangement.
Yep. And kind of, I guess also the shape of from the part of that spatial arrangement is the shape of those areas. So if they're like long, thin areas, or if they're like rounder areas, they've got kind of a blobby. Like you could have the same area,
yes,
but the shape of that area or the shape of those areas, or whether they're lots of little small bits dotted across the landscape.
Yes. So one simplified way of thinking about it is, do I, from the perspective of species, have stepping stones that are within striking distance, within the area, the distance that I can manage in my lifetime? And if you've got a series of stepping stones, then it's quite likely that you're functionally connected. But if there's a gap that's just not possible to cross in one lifetime, then that's probably a problem.
Yeah.
And it's the problem that then species are just kind of constrained to one area and then it limits.
Yes, yeah. And that is actually can be okay if the climate isn't changing or if threats aren't encroaching on that area. You can plan to conserve a species in a super small area, and that's happened in New Zealand.
I mean, we have those sort of island reserves are the classic example of that, where we have a very small offshore island and we have a very rare endangered species that maybe once was spread across the entire South Island, or both islands even, and that classic example is the takahe, which we were up at Orokonui the other day.
Well, very nice.
They're so beautiful.
So amazing. And at the moment, they've got the juveniles from the last clutch helping with the new juveniles. So there was actually, I think, 6 birds there, weren't they? And they were just there.
And I can't believe they put 2 benches there so that, young kids, grannies, anyone can go and see them.
Yeah, and it's really amazing because you kind of forget how rare they are because they're right there in front of you and you just, you walked 100 metres basically and you can see them. But and of course they were much more common at one time because they were over most of the South Island, at least, sort of. But then they were thought to be extinct for like 60 years. And when they found them, they were in one little valley now called Takahe Valley, which is quite high altitude, quite isolated, and basically where introduced pests hadn't managed to drive them extinct.
Yes, and they probably benefited from that lack of connectivity back then.
Yeah,
and if the climate was stable there, and if you could preserve that situation, then they wouldn't necessarily need connectivity. It's especially under climate change, when where there's a moving threat, then that we need to think about connectivity and conservation.
Yeah, and it's a good point there because in terms of the takahe, the threat might not be the connectivity of the species itself or the change to the species itself, but with the climate warming, stoats and predators being able to move into that higher elevation, then that what was a refuge becomes a bit of a dead end.
Yes.
So luckily, the takahe were found, and it's a fairly good news story at the moment.
It is. Long may it continue.
Long may it continue.
So is this part of the conversation around hedgerows in the UK, about hedgerows provided connectivity, and when farms were wanting to make their farmers larger farmers, that they were taking out the hedgerows?
Yes. In the UK, Western Europe, and other places where there's been agriculture for a long time, a lot of the species that we're trying to conserve are dependent on those traditional farmland habitats like hedgerows. And we do worry about, we try to provide features, small habitat features may be our stepping stones, whereas in other countries, the conversation may be more about truly primary habitat that has not been significantly altered by humans.
I wonder if you could tell us some of the work that you've done with those hedgerows, or I think you've done some work with butterflies there, did you?
So I co-supervised a PhD student that did some field work on butterflies along field margins in northern England, as well as some modelling. So I supervised the modelling part of this particular project. And so this looked at whether investment in setting aside field margins that you could potentially plough up, is that investment creating connectivity for butterflies? And the answer was probably yes, given the amounts of hedgerows and field margins that there are.
So it was
in the
worth
UK
keeping
landscape.
the hedgerows and the field margins. And I guess that's really useful information for the nature conservation groups and the sort of government conservation department, but also for the local farmers.
Yes.
So this,
I think it's it's very useful to demonstrate the benefits from different points of view of these agri-environment schemes, but also to remember that these are benefits for farmland species, and there are a number of really habitat specialist species of butterfly and moth and other, in the UK that won't really ever venture into farmland. So we have to have a little bit of a mixed strategy for the more widespread farmland species and a strategy for the more specialist species.
sort of forest
species or heathland or wetland.
So then when we're talking about moths and butterflies, like, do you engage with farmers around pollination, or is that the kind of approach you take? Or?
That's a really good question. I think it's super important to engage with farmers, and another of my PhD students has just been starting some farmer interviews, so she's really interested in humanities and social science side, and she didn't want to finish her PhD without doing some qualitative research and finding out what motivates farmers to create, in her case, meadows. And she's been asking them what are the barriers they face to creating traditional hay meadows, what are the benefits they perceive. If they think about pollinators at all, do they at all think about how far the pollinators might move?
Right, and she got
those results aren't out yet.
Oh, wow. No, but it's really interesting though, isn't it? Because it's taking it from that totally opposite point of view, or not even opposite, but just a different point of view, where you're thinking, you know, functionally, I'm a small farmer. I have a small patch of land here, and I imagine there's quite a tendency for people to think, oh, it doesn't really matter what I do. Yes. I have a small area. I have an influence over a very small area. But of course, if everybody thinks that, then it becomes quite a big trend. And of course, you can get these sort of perverse incentives which I guess is where the conservation bodies and the government might play a role, because if there's an incentive to, I don't know, just make money, or if there's an incentive to have one form of land over another, or bigger patches, or more joined up patches, so you can, like, that's really valuable information then, because once you know how big they need to be, or how long, or how connected they need to be, or, you know, if you can get a whole group of people who are farming in a similar area, so that you can get those networks more connected if they need to be. Yeah,
something that the farming incentive schemes have changed quite a lot in the last few years, and people here might not be at all interested in them. But one thing they've started to bring in is incentives for cooperation, so landscape level schemes where landowners club together to propose a set of actions they're going to do and get money
so
for
a group of, so say in a catchment, so in one valley or something, then a whole group of farmers could get together and say, we're all going to do this, and then the result for conservation will be larger than the kind of sum of the parts, basically. And I guess we kind of have a bit of an idea around that with pest management in New Zealand, which quite often is led by something like Predator 2050 or Osprey or something, and particularly with possum control, because of the TB carrying aspect of possums here. And of course here possums are a big threat. So and and obviously if you get rid of them on your farm, makes no difference if the
You don't get rid of
person
them
next
from
door.
yeah, still got them.
That's always done on a sort of a catchment basis or a regional basis. And
so I was going to just say, for context as well, perhaps a big difference between our two countries is that if you look at the sort of public sector budget for conservation in England, more than half of it is paid to farmers to do actions on farmland.
That is...
And that may be true for pest control in New Zealand, but I'm sure it's not true for farming.
I wonder if
it's absolutely not true. Yeah, no. So in I think the 80s, when the UK, not to place any blame here, but when the UK joined the EU, prior to that, a large proportion of our primary produce went to the mother country, Britain. And then when the UK joined the EU, that kind of one-on-one relationship changed, and then we went to this whole free market idea. And Trudi, you can just interrupt me when I'm going wrong here. Well, basically we got rid of all the subsidies to farmers.
They did have a decade to adjust because the UK went to the EU in the 1970s.
I suspect that for farmers a decade is not that long.
but it's interesting because the same impact with the UK and Brexit and the loss of subsidies in farming. And does that?
I don't know. They promised that they were going to maintain the subsidy levels, the overall subsidy levels. But I'm not an expert on whether that promise has come through.
Yeah.
From 2016 to now.
Yeah.
It
would be totally you might expect.
Yeah, it would be totally unusual for politicians to promise something and then not follow through. When does that ever happen?
Hold on a minute. Do you want to step outside? Yeah. But I just thought that might have been where that, why that spend at that government level was so high in terms of the conservation, or is that a traditional thing?
It was the case under the EU as well.
Right,
yeah.
okay.
It's been. And I think, it is something that I think that New Zealand should think about again, because there is a lot of land in New Zealand that's under public conservation land, but there's even more land in New Zealand that's not under public conservation land ownership. It's in private ownership of some form or another, and most of that is on the east coast and the lower lands, and most of our rivers run through that. And currently our freshwater, and we will have someone later in the year talking about freshwater, but just now in summer we see, we have this sort of international idea of clean, green, pure New Zealand, but really our waterways
in the summer they disappear.
Our waterways have been deteriorating a lot, and a lot of that is through perverse incentives, where we, riparian zones and that is a place where I think there is a place for, personally, I think, speaking not on behalf of anyone.
And a place for looking for connectivity as well.
A place for looking for connectivity.
Of restoration of restored habitat.
And restored habitat, and that riparian strip that is keeping our waterways cleaner, I think, and particularly with our freshwater fish, which are very endangered. Almost all of our freshwater fish are very endangered, both from changes in the riparian habitat there. We've got a lot of introduced willow and things, and our braided riverbeds are full of weeds, and pretty though they may be, but also with the introduction of trout. Which and that's it would be really interesting to do a connectivity study on that, because trout are less good at climbing than our native galaxid species. So putting in culverts that can be quite high, the little native galaxids are very good at climbing them, but the trout aren't. And perversely, the trout just eat all the native galaxids. So most of our little natives hang on in inaccessible areas. So, so that sort of connectivity, of course, in the general land terrestrial habitat, you might want to speak to this, is different in a couple of ways, but also similar in ways to freshwater connectivity.
It's definitely different because the water's moving things along with it in one direction, whereas on the land, I feel comfortable using a very simple model where an organism is as likely to travel north as south. Or
I mean, of course, there's upslope and downslope on the land, and there's wind patterns and stuff, but you don't want to go overboard in the detail.
So when we talk about organisms travelling, why are they travelling? Are they travelling to seek better habitat, or is it just part of their natural life cycle?
It's part of their natural life cycle. Yes, they don't need to be informed about where they're going. A certain fraction of animals always will travel a particularly long way, and same with seeds dispersed by the wind or by animals. A small fraction of them naturally will travel a long way, and they've evolved to do that. And it's not necessarily that they do it any differently under climate change, but under climate change, a new section of land, let's call it land, has become available that is now suitable for them that they've never inhabited before.
Okay.
At the cooler edge of their range. Yeah. And if they get there, they will survive. Yeah. And that's what we see in the data for species shifting their range in Europe, particularly, where the data is quite good.
So
which is an
the
important
conservation thing is about how we get them to those.
Yes.
Yeah, so it's quite important. There's two, I just want to go back to two little points that Jenny raised there. The first one is I don't think they're drawn necessarily to that space that's there, but previously they landed in that space and just died because it was too cold or too whatever. But now that the weather might be more benign, fit in their climate niche, whatever that is, they're able to survive.
Right.
Previously they died.
There,
so it's not sort of like
it's not like
I can see the Bahamas over there. I want a holiday. So it's kind of like they were always dispersing there.
But this time they're going to survive.
But this time more of them can survive.
Right.
And I think that's particularly important for New Zealand because we have quite a few self-introduced species from Australia, which we kind of think of as a different category to invasive introduced species. And they've probably been blowing in various ways, plants and a few insects and birds as well. Dropping in for millennia maybe, but just dying.
But now they're going to be able to survive.
Some of them have started surviving because not through climate change, but through habitat change. Because most of New Zealand was forested, and if they're not forest species and they fall in a forest, they tend to die. But then with all the land change, so if you think of New Zealand as almost entirely forested with a few alpine areas, and then Polynesian fires taking about a third of that forest into non-forest area, and then European land wanting wood for various things and farming farms, that's another third of the land gone. So there's a huge habitat change that's happened in a relatively short time, and so there's different types of habitat that now those blown in
like magpies,
vagrants can come in.
So in terms of the theory that I use in my work that I use for my modelling, actually was started in the 1950s thinking about invasive species.
Okay.
And it's called invasion models or the mathematics of invasion. And it was obviously started by thinking about pests, but it's the same process. You have to disperse, you have to be able to breed. And the more you breed and disperse, the more the invasion continues. It's the same process that's happening as new climate space opens up for species. So we can just borrow that theory. We don't need to do some new theory.
It's great, eh? So you're sort of applying the same sort of rules and theory that's been around, but just applying it to a new context, yeah. And it's really useful in the New Zealand context because everybody here, I think, is, the whole idea of, like, even people who've never touched a science book are aware of the whole idea of invasive species and stuff. And Jenny, could you elaborate maybe on some of the cool work that you've been doing along that modelling and your cool modelling?
Yes, so I started doing this modelling of how, in general, the spatial configuration of habitat would affect the speed at which species could travel a long distance, like many, many generations, something that they could never do in one generation. And I started that in, I think, 2011, when we were still working together, doing that modelling. And it's become, I found a useful summary metric, and that can summarise how quickly or slowly, how easy or difficult it is to cross a landscape from one end to the other. And I'd already been talking to conservation agencies and charities about their issues of trying to plan conservation under climate change. So I knew they were asking the question, well, we know we need to restore some habitat, but where does it need to be?
Right.
And so fairly soon after doing the first modelling paper, I said I should make this into some software so that anyone who wants to can calculate these speed values. We call our metric speed to try and make it more simple and accessible in the model. And so this became, after a few years, the software that's now called Condatis.
And where does Condatis come from? What is a name like Condatis?
It's the name of a Celtic god of the confluence of rivers.
Oh.
And one of my partners from a conservation charity actually came up with the name, but I thought it was so good. Had to...
Gotta love a little bit of Celtic naming in there.
Yeah.
Always up for that, always up for that. So what, if we wanted to apply that here in New Zealand, what would we need in order to apply it to a New Zealand context?
So the inputs are very, very simple. It's your spatial map of your habitat, where you can have, what is habitat, what's high quality, low quality habitat, and what's...
So we'd need to know what species we're thinking about,
yeah,
and what their
a species
habitat
or a group
is.
of species, and then, or if you need to do multiple scenarios, you need to run it multiple times for the different needs of the species. Yeah, so each run, let's say, you'd need a map of habitat, and you'd need your expert opinion of where the species are travelling from and to.
Right.
Which we call the source and the target.
Yeah, so we need some idea of where the species that we're interested in are currently, and what sort of habitat they like, for want of a better word, anthropomorphising slightly here, survive best in, or survive okay, or don't survive at all.
Where they can breed and
reproduce, yeah.
But aren't we doing that in our current climate?
Yes, the source would be the area that's suitable in the current climate, and then if you were interested in adaptation to climate change, resilience to climate change, then you might well set the target in an area that is a little bit too warm currently, but will become suitable.
Right, so you can adjust your target to account for climate change.
Yeah.
Oh.
Yeah. And
then you just need the average dispersal distance per lifetime of the species.
Right. The average dispersal difference.
So how far?
Is that the mean?
So,
some sort of dispersal?
Yes.
Is there some sort of dispersal distribution?
There's a distribution.
With some sort of long tail?
Yes. So there's about, if you set your mean, then is 1 kilometre, about 4.5 kilometres, you'll get a couple of percent of the individuals going that far. So and so on into the distance. There will be a tiny probability of travelling 10 or even 20 kilometres.
Right.
But that will make, if there are gaps that big in your habitat distribution, it will make the speed extremely slow.
Right. And can the same software be used for invasive species as non-invasive species?
It could be. Actually, somebody that I wasn't collaborating with used the same technique for an invasive moth in the Greater London area.
Did it
Tried
work?
to look at where the moth would arrive. It showed areas of higher and lower connectivity. Yes, it did
Right.
work in that sense. It is, let's say, simpler to run this model if the species you're talking about doesn't have much habitat available, say less than
Right.
50% of the landscape is habitat.
Right, because then it's dying in more
And
places,
for many
right? So it's more
invasive
directional.
For many invasive species, from their point of view, they have quite a lot of habitat available in the landscape.
Because
There
that's
isn't
why
really
they're
anything
invasive
that-
species, right?
That's why they're invasive species,
Yes,
or can be why.
The ones that have very little habitat available to them tend to not do well, potentially, as invasive species, yeah.
Yeah, so you could run the model for an invasive species, but if it's got a lot of habitat, the answer you get will be pretty boring, which is, yeah,
It'll
it
just
can
go
get
anywhere.
everywhere.
It can go everywhere, yeah. Anyway, I guess it could, like, I was wondering sort of more, would it give you an idea of how much time you have to address a problem of a species like the wallaby moving from Waitati further north of here into Centro Otago and Otago and Centro Otago through there. And so it sort of might give you more of an idea of the time buffer
Yes.
that you may or may not have, with all the appropriate
Yes.
caveats around the fact that this is all a probabilistic model and things may happen faster or slower.
Yes, you could, but for species, individual species where we know a lot about them and they have a particular economic importance, it's perhaps worth running a simulation model instead,
Right.
a model with many more details of the individuals, their individual fate, and exactly how many babies they have. Whereas
So
my
more
model is much
individual-based
more-
model, and yours is
yeah.
kind of more of a, you can run this for a lot of species that you know a little bit about.
Exactly.
Yeah, which is quite good, isn't it?
Yeah, very good.
Yeah, I like different models for different things.
Well, of course.
Different models for different
You
things.
get the right tool for the right job.
right tool for the right job. Yes, you get some people, they think hammer, they see nail, think hammer. How
Well,
does it
you
go?
use the hammer for everything.
I can't even remember how the saying goes. Oh, it's
Yeah.
new year. I'm just absolutely awash with.
So yes, so the whole concept from the beginning was trying to design a tool that would work with the kind of data that conservation organisations normally have, and not demand sort of individual level birth and death data or anything like that.
Yeah.
But at the same time to be more dynamic than a habitat suitability model, which would not have anything about dispersal in it at all.
Right, so it's kind of, halfway through. It's got a little bit more information, but not a massive amount, so it's kind of... and has it worked? Is it easy for conservation bodies to use? Has it been shown to work in different places with different species, or is it still just kind of a theoretical model that scientists use?
Yes, it's been used quite a lot. It's been used by scientists and non-scientists. We think there's about nearly 100 conservation user organisations that have signed up to our website and used the model in some capacity. We don't always know what the results of that have been. But there's a few nice case studies. For example, a project called the Northern Forest in England is aiming to plant 50 million trees across a belt just above Wales, if you know the UK at all, between Liverpool, where I work, and York, where we used to work.
Oh, wow, that's very relevant, isn't it?
50 million trees by
What kind of
2050.
trees are they planting?
Any kind. So it's
Like
it's
native
quite
to the UK, though?
broad-based. Probably native, but not even necessarily.
Oh, wow.
So it's quite a broad-based project that aims not only to improve connectivity for climate change, but to absorb carbon, to address air pollution issues, to address health and well-being issues in some of these areas in the north of England are quite economically deprived and don't have a lot of green space So it's multi-objective project, like many of these large projects are, and connectivity is going to be only a small part of it.
Right.
So they used Condatis as part of their scenario analysis to steer where trees may be planted, but there are lots of other considerations too, like these considerations of where the health benefits and air quality benefits would be greatest.
That's quite interesting, though, because you can sort of, at least you've got the information there and you can kind of trade it off and go, okay, because there will be many more places where you could add things, and then you get to say, okay, well, these are the places where connectivity would be great,
Yes.
and then overlay that over air pollution or population bases, which I guess air pollution and population bases are probably quite correlated somehow. So it's more people, there tends to be more air pollution. Trudi.
I was going to say, that's quite an amazing project, yeah. So, because you have to get the land and then the trees and people to plant them and then,
And it's nice to see something
many partners over many, many years. So
it's nice to see something that you've done as a sort of theoretical thing
turn into
actually being used on the ground and making a difference.
Yes, and that I couldn't have imagined that when I started it, sort of 12 or 13 years ago. And it does really motivate me working with the partner organisations and talking to them regularly, finding out what they would want to see and what they find difficult, or what affects the chances of a model being used.
Yeah. And has it been used, you said you've got a few case studies there. What sort of scales has it been used on? So like...
Sometimes at quite small scales, but I would always advise people that it has to be several times that the organism's generation dispersal distance that you're thinking of.
But for something that's got quite like a relatively small generation dispersal distance, it could be a reasonably, like a catchment size, couldn't it?
Yes, and we had funding to do some work with partners in Indonesia, Malaysia and Ghana. And for those, they did tend to use it, well, in Indonesia and Ghana anyway, they tended to use it on quite a small spatial scale between two protected areas that had a potential corridor between them, for example.
Okay, so what sort of scale?
That would have been less than 30 kilometres.
Oh, right. So that is quite small, isn't it, really, in terms of, Useful. And what sort of species were you looking at there moving?
In Indonesia, they were particularly interested in the Javan gibbon.
Oh, nice. A gibbon.
So, yeah.
Wow.
And in Ghana, we didn't have species-specific data at the time, back in 2018 when we did it. And since then, we've started to build up a little bit of species data, mainly on birds and mammals.
Yeah. And I guess that's where most information starts, isn't it? Birds and mammals, even in New Zealand, birds and mammals. And the insects come later because they're much more important. There's many more of them. Speaking from a biased point of view. And then the plants.
But do the insects normally accompany birds and, well, not always. Sometimes, I don't know, perhaps, Yeah,
I don't know. I think the thing always is that you tend to have more data for groups of species that are bigger and
humans love them.
So, I was thinking about, like, with the gibbon and, insects versus birds and mammals, we tend to get more information sooner about, they call it fur and feathers here, but, bigger things, pretty
things that humans love. And also there's an aspect of them being easier to spot, record, identify.
Yeah. And quite often I think that it goes with having a good guidebook.
Yes.
And all that work that taxonomists put in is what makes ecologists able to do their jobs, and all the work that ecologists do out in the field is what makes theoretical biologists able to do their jobs.
Yes, I've certainly benefited from a lot of citizen science data in my career, doing science on these large-scale data sets of where species were in the past and where they are now.
Yeah, and I guess in New Zealand, our that's come leaps and bounds since we've got iNaturalist, because of course all the British stuff started with the vicars with nothing much to do, 6 out of 7 days of the week, going around with a little notebook, writing down what was there, and then we get these amazing distribution atlases for the British Isles, which of course people were busy doing other things in New Zealand. They didn't have.
You're not suggesting that New Zealand doesn't have enough vicars?
I'm not suggesting that we don't have enough vicars, but just as a sort of a
that would be a serious sidetrack.
It's a serious sidetrack. No, it's just sort of musing on the the social aspects of why Britain has all this amazing atlas distribution data, where it started from, and that kind of obviously it's not just vicars now; it's a whole heap of people of. Some may even be atheists, enthusiastic amateurs. Yeah. But that system kind of, I think, started from that kind of vicars going for a walk around their parish and just noting down every week as they walked around the same track, or every day, what they'd seen when they'd seen it, that sort of going for a nice amble type thing. Whereas I think Kiwis, when we go into nature, we go into the bush and we kind of perceive the kind of green nature bush, but we don't necessarily note down the species that we've seen on that particular walk, or even, a lot of people don't even really take much notice of what species may or may not be there. It's nice to be in the bush, but bush is correct me if I'm wrong there, Trudi, what do you reckon?
Although, I was just thinking, who did we interview not so long ago who was a real bug enthusiast? And I just imagine it was a small boy down on his knees with a... Yeah.
Oh, that'd be Dr. Robert Hoare, I'm sure.
Yeah, but
he's from the UK as well. So.
Oh, well, yeah. I just wonder if it's a function of population, there might be more bug, where do your conservation groups get their data from to put into your model? Is that...
That is from those amateurs.
From amateurs, citizen scientists. And I was just thinking when you said that about how it is population-led. We do, within the UK and across countries, we have more species data where there are more people living. And that can sometimes be a bit of a headache to disentangle the effects of recording effort, we call it, from the effects of the real abundance of species out there.
I know what it was. It was the DNA drive thing.
Oh, right.
There is definitely a competitive kind of element to it. I'm sure everyone knows about competitive kind of birding, but
not necessarily.
Political boundaries matter. So in England, it was the counties. So if you had the first record of a species for your county, you'd rush to record that and send a letter to your natural history magazine and say, I found the first of the species for my county. So we've got a much better, you could make a very reliable list of all the species in each county, for example. Yeah. Before the Second World War, if you wanted to.
Yeah. As opposed to
but not
10 kilometre squares or 5 squares. Yeah.
So it's a different cultural approach, eh?
Yeah.
It's definitely a cultural phenomenon.
Yeah, it's definitely a cultural phenomenon.
It's not just science.
Yeah. And it's true. It's true what you say about competitive, because birders tend to be competitive, I think, much more so than insect folk. And I suspect that...
I don't know. I think there might be...
Jenny's looking at me dubiously there. I'm going out on a limb here. And my hypothesis is that it's because there's so many more insects of all different groups. And...
Yeah, but people can get competitive about anything. There's also the insects that are super rare. It's so hard to find, They're just as exciting as the super rare birds, I think, to those...
For the competitive
who get
aspect.
Into it,
yeah. Okay.
So how do you get into this competition? It must be I'm naturalist.
You just start. You just start making a list, and you make that list publicly available somehow. Yeah. And I would say iNaturalist is the best way to do it in New Zealand. Yeah. And the thing is that people, when they, have you ever been competitive about distribution spotting?
Personally, no. No.
But we both know birders
Yes,
who
we
are, and they're just out there for the ticks. So they have a whole set
Oh,
of,
like train spotting, you have a list.
they have, and they don't have a list, Trudy. They have many lists. So they have the 2026 list. They have the this location list. They have their lifetime list. They have all sorts of lists. Honestly,
It's a really good app, apparently called Any List, when you can create, and then you can share it. And
am I missing some of those lists there, Jenny? I honestly, I've put my foot in it on numerous occasions, being in mixed company, by which I mean people who are birders and people who aren't birders.
And you can bold over if someone spotted something.
No, I've just, made some
Comment about
off-the-cut
Twitter.
comment about lists. Being told I don't know what I'm talking about, which is not an unusual occurrence, really. Anyway. Right. Thank you very much, Jenny. Cool. Now, we didn't really get onto conservation prioritisation. We do have 4 minutes left.
Pressure.
Well, connectivity sort of leads on to conservation prioritisation. And we did sort of talk about...
Yeah, so I have a paper that came out just at the back end of last year, and it links to the citizen science thing, if I could just mention about that, because it tries to link together citizen science data with a whole collection of more structured surveys that have been done in different habitats, and figure out on a global level how bad it is when native vegetation gets converted to farmland, intensive farmland or low-intensity farmland, accounting for the species that we know very little about. And so the way it's relevant is that even though we have very spotty, patchy data on some of these rare species across the world, as long as we have some that's been collected by citizen science, we can use what's called extrapolation to make a best guess about how those species would respond to land use change, even if we haven't been out in an experiment and measured it. So that's another aspect to my work, apart from the connectivity modelling, which is trying to think about connectivity indicators and trying to think about how we can summarise how a huge group of species responds when we don't know anything detailed about any one of them. And ultimately, the two could come together if all you have at a large, say over a large continent, is a map of the habitat types and some citizen science data about the species, which has loads of gaps in it. You could build a conservation plan by estimating the number of species that depend on habitat A, the number of species that depend on woodland, the number of species that depend on heathland or a mixture, and so on. And then, instead of having to run Condatis or your other model 50,000 times, you could just run it 20 times, say, for the different groups of species.
Yeah, which is a big saving in computing time, but also possibly easier to actually implement as well.
Yeah, and easier for people reading the results, the people that need to understand the results to understand them.
Yeah, so it's not just a saving in computer timing, it's actually kind of a synthesis type approach, I guess. And
do people get upset that it's extrapolated and not actual?
I think some people would always get upset.
Yeah, well, that's true.
But I would argue what's the alternative? It's only being able to make conservation plans for the species that we know a lot about for historical reasons.
And even then we don't have perfect knowledge of. I mean, we don't have perfect knowledge of anything, that kakapo accepted. But, it's when things have got to the point where we have perfect knowledge of every individual and where it is, then it's past the point of sort of being a wild system anymore, basically. It's at that dire end. Yeah. And then we're only doing things at the cliff face. And I mean, there's a lot of species that actually need to be common in order to survive. So the passenger pigeon being the the obvious example. I'll leave it there. Hey, thank you so much for coming all the way from your busy schedule in the UK.
You're so welcome.
Just to be on the show.
Just for this interview.
So, yeah.
And it has been a fabulous conversation. It's slightly more like winding than perhaps I led you to believe at the start. But it's been great. Thank you very much.
Thank you, Barb and Trudi.
You've been listening to the OI podcast with Dr Barb and Trudi in conversation with Dr Jenny Hodgson from the University of Liverpool, talking about connectivity and conservation prioritisation. Thank you for tuning in. Please like, subscribe, follow all the things, send us comments on Facebook and spread the word far and wide. The OI podcast. You've been listening to the OI podcast, the shout out for the arts, sciences and Mataranga Māori.
You can support this podcast by becoming a member of the OI. Check out the Otago Institute for Arts and Sciences on Facebook or our website.
If you'd like to listen again to this episode or others from the series, look for the OI podcast on ORFM's website, oar.org.nz.
Brought to you by the Otago Institute for Arts and Sciences, the Otago branch of the Royal Society of New Zealand.
This podcast was produced by ORFM Dunedin with support from New Zealand On the Air.